Hello, hello guys. How have you been? It's good to see you again. ¿Cómo están mis estimados
Hello,
aprendices?
happy Thanksgiving.
Hey, you too. Thank you. Aish, hold on.
Happy Christmas.
Not yet Christmas, but thanks a lot. Okay, let me fix the audio of this. Let's see, echo headset. Yeah, better. All right, guys. We're going to today we're going to continue study linear inequalities, but in this situation, there's going to be another variation, and the name of this inequality is that conditional inequalities. Why conditional inequalities? Because we have condition could be one or another thing, or one and another thing. All right. This is the name because we're going to join these two inequalities by this condition. It could be the word or we can use the word and. But at the end, the process, the way we're going to solve these inequalities will be the same. How are we going to proceed to solving these inequalities? Because we have two different inequalities, we have to solve for every one of them. For example, in the first one, we have 2u plus 3 less than 7. You know, 2u will be less than 7 minus 3. 7 minus 3 will be 4 units, right? And u will be less than 4 divided by 2. U will be less than number 2, okay? We are providing the first answer of this inequality, okay, with one hand. Not big deal. Let's going to provide the second solution. Negative 3u less than equal than 17 minus 4. Okay, you know, negative 3u less than equal than 13 because you know 17 minus 4 will be 13. And remember, what happened when we have a negative number? A negative
We have to
number.
switch places so it becomes positive.
Well, in this case, will becomes negative because we have 13 divided by negative 3. Positive times negative will give us negative. And in this case, the value turns negative 13 over 3. But even though, because we have the negative number multiplying the letter u, we're going to switch the orientation of the inequality. Okay? And this is going to be the solution of the second inequality. Remember, every time that we have a negative number multiplying the variable, we have to be, obviously, we'll change the final sign of the number, and also we're going to change the orientation of the inequality. Understood? All right, then. Before to provide these answers, because remember, we have to provide the answer using table notation, solution set, and number line. I strongly recommend in this condition inequality start from that number line. This is a recommendation. All right, I'm not saying you have to do it following the same order, but it's going to be easier for us to determine the solution set and determine notation by the number line. For example, we have the number 0 between them. This is approaches the number negative 13 over 3, and we have the number 2. Okay, so we have to graph according what the problem says. For example, in this situation, okay, says values less than number 2. What are the values less than number 2? 1,
And
0, negative
zero,
1,
negative
negative 2,
one,
so
negative two,
on.
negative.
Okay, I'm going to draw the circle, but because I'm not including the equal sign, I won't paint it or stain. So this arrow will be located to the left side, right? And about with the second one. And the second one, as soon as you can see, The problem says values greater than equal than negative 13 over 3. Obviously, will be the entire positive values, okay? For that reason, the arrow will be located to the right side. So I'm going to draw the circle, and because I'm including the equal sign, I'm going to stay in the circle, and we're going to draw the line. Oh, if you see, there was a collision between them. All right, so the solution given by the number line, it is number line, okay? This is going to be the number line. Now, as soon as possible, you can see we have a intersection point between these two numbers, okay? If you remember, okay, the interval notation, as soon as you can see in the number line, it will be between these two numbers. For that reason, in the interval notation, we got brackets negative 13 over 3, comma, 2, open or close the parenthesis, because the first one we included the equal sign, and another one I don't include. It doesn't include the equal sign. For that reason, this is going to be the solution of the interval notation. All right, and at the end, if you remember, because there's intersection between these 2 points in the solution set, will be given by negative 13 third less than equal than x less than 2. This is going to be the solution set. And that's it. That's all that we have to do in this kind of inequalities. I strongly recommend, all right, every time they want to provide the answers, please do it in the first place, the number line, because it's easier for us identify where's going to be the intervals and where's going to be the solution set. Understood? Understood?
Yes.
Yes, Mr.
Okie dokie then. Let's go to solve another example. Okay, the letter B. Letter B. The letter B mentioned 2a plus 3, 2a plus 3, 2a plus 3 greater than 7, and this is another condition, and negative 3a plus 4, negative 3a plus 4, less than equal than negative 17. Okay, less than equal than negative 17. All right. What we're going to do in this situation, because we had another condition. The first one was or, the second one will be in. How we proceed? In the same way. In the same way, we had to solve both inequalities, but at the end, we're going to provide the solutions, okay? So in the first one, you know, 2a greater than 7 minus 3, 2a greater than 4, a greater than 2. Okay, not a big deal, simple. By the other hand, negative 3a less than equal than negative 17 minus 4. You know, negative 17 minus 4 will be negative 21. Negative 3a less than equal than negative 21. Okie dokie. And because We have a negative number multiplying a. Remember when the passes to divide, you know, negative 21 divided by negative 3 will be positive 7, right? And we're going to change the sign of the number and the orientation of the inequality. For that reason, a will be greater than equal than 7. Okay? Now it's time to provide the answers. Okay? First of all, strongly recommend, in this case, starting from number line, because it will be easier for us, if you grab the number line first, will be easier for us to determine the terminal notation and solution set. Okay, we have the number line. If you wish, we can graph -7, -2, 0, 2, and 7. This is an option. Or if you wish, we can graph only 2 and 7. Don't worry. Let's going to start with the number 2. What values are greater than 2?
3,
Three,
4,
four,
and so
5.
on.
To the right side, right? So I draw the circle without a stain because I don't include the equal sign. And this is going to be to the right side, right? How about with the number 7? What values are greater than equal than 7?
7,
7,
8,
8,
9,
9,
10.
10.
9, 10,
Okay.
11.
I'm going to draw the circle. Stay in the circle. And oh, once again, we have a collision between these two numbers, right? Okie dokie, because there was a collision, these two numbers. This is going to be the solution set using the number line. Okay. Because we know we have a collision between two numbers, we can perfectly know what will be the interval notation. Remember, the interval notation will be the intersection between these 2 points, 2 and 7. Parenthesis because we're not including the equal sign, bracket because in the other one include the equal sign.
Equal sign.
This is going to be the interval notation. And at the end, the solution set will be between these two values. For that reason, the solution set will be 2 less than x less than equal than 7. This is going to be the solution set. Actually, in the rest of the inequality, we provide the 3 answers, but in the opposite order. We provide solution set, interval notation, number line. But remember, the order of the factors doesn't affect the final result because at the end, all of them will be the same. Okay, but the most important thing is you try to understand what happened with these conditional inequalities or an n. Let me looking for another model of the same inequalities. This is going to be interesting. The letter C. And let me show you what happened in this case, what we're going to do in this case. In the letter C, we got 4x plus 5 plus 5. Okay, 4x plus 5 greater than equal than 25. Okay, for one hand. And the problem says, and 3x minus 4, 3x minus 4 less than equal than 2.
Yes.
Okay, remember, it's a conditional inequality because we have the words and or. Okay, it doesn't matter the word, but the important thing is to have conditional inequality, we have to separate the solution between them. So let's continue. In the first one, 4x, that will be less than equal than 20 because 25 minus 5 will be 20 and x will be greater than equal than 5. How do I know? Because, how do I know? Because 20 divided by 4 gave us 5. Okay? This is for one hand. In the other hand, we have 3x will be less than equal than 6 because the number 4 is subtracting, passes to adding, and you know perfectly well 2 plus 4 gave us 6. And because the number 3 is multiplying, passes to divide, and we can conclude x will be less than equal than 2 because 6 divided by 3 gave us 2. There is no changing orientation in this case, right? We have the in the normal orientation. Now, this is the moment of through. We're going to start from the number line, okay? This is the number line, and we can graph the number. I'm going to graph the number 2 here and the number 5 here, okay? So, what values are greater than equal than 5?
5, 6, 7, 8, and
5,
therefore
6, 7, and so on, right? So we can drop the circle, stay in the circle because if we have the equal sign thing, we have the arrow located to the right side. How about the number 2? What values are less than equal than 2?
2,
2,
1,
1, 0,
0,
and
negative
negative
1,
numbers.
go on.
And go on, right? Perfect. Because we have the equal sign, I'm going to stay in the circle and oh, we have a different number line in this case, right? We have a separating solution in the number line. So what happened in this case? Well, if you're asking for, but Mr. in this, according to this number line, I have to involve the solutions negative, infinite, positive, infinite. I'm going to tell you yes. And how we can do that? We're going to provide, how to say that, apart
2 different?
the interval notation, but at the end they're going to join them. Let me see. You know, the values less than equal than 2 will be the entire negative numbers onto the number 2. That reason we have negative infinite, comma 2 brackets from this side. Okay. By the other hand, the values greater than equal than 5 will be since 5 until infinite positive. Okay. But we cannot leave the answer just like this one because even though we are falling apart between them, both are the part of the same inequality. For that reason, when this happens, with arrow, one arrow for the left side or one arrow for another one, we're going to connect both interval notation like using a letter U. This letter U means union because they're going to join the two inequalities. Understood?
Yes.
Okay, so in this case, this is going to be the interval notation. And that's going to happen if and only if at the moment we're going to graph the number line, we have two arrows in opposite directions. Okay. And finally, the solution set. Someone says, okay, mister, we have to use the word and or. Okay, in this situation, because even though we have the word and, okay, because the arrows, their moves in opposite directions, when this happens, I'm going to join these two in a solution set using the word or, because or is a one condition between una u otra cosa. Or means in opposite directions and means in the same direction. Okay, for that reason, at the moment I'm going to provide the solution set. In this case, every time that we have split arrows, I'm going to say, all right, x less than equal than 2 or, because or means opposite directions. X greater than equal than 5. And this is going to be the solution set. Okay? Because or means opposite directions, but it could change. It could change. Could be have a, even if you remember at the beginning for this equation, we have or, and at the end we are joined these inequalities, right? As soon as we can see and that means join together. Well, we have the join together, but in this situation, even though we have the condition and at the end, the arrows moves in opposite directions. When that happens in opposite directions, don't forget to provide the solution set using the word or. Even though at the beginning we have and. And means joined together. Okay, that means. And even though if you ask me for, Mr. In the problem B, we have 2 less than x and x less than equal than 7. This is the only way I can write the answer? No, this is the common way. Another way to say in this situation, we're going to tell, I'm going to tell you a greater than 2 and a greater than equal than 7. This is another way to express the solution set in the letter B. This is another way to express the solution. Okay, if you want to spread the solution in this case, but I think it's more multi presentation using the first one, the 2 minus less than x less than equal than 7. But if you want to use the second one, the purple one, it's acceptable. All right. Questions? Preguntas? No? Okay then. So in this situation, we're going to finish the lesson of the inequalities. You know how to solve linear equations. We learn how to solve the classic linear inequalities. You learn how to solving compound inequalities and obviously the conditional inequalities and provide the answers in the 3 ways that we as know: number line, table notation, and solution set. Okay. Well, this is going to continue solving one kind of linear equations, an extension of linear equations. This is what we call, the name of this situation we call proportions. Proportions. What are the proportions? The proportions are rational equations. The proportions can be defined like a rational equation. Like a rational equation, sorry. Rational equations. Equations. What will be the force of the proportions? For example, if I have one single example like a over x equals b over c. Just for to give you an example, this is a rational equation where a, b, and c, a, b, and c, a, b, and c are numbers different and then 0. It's in simple many words. How we can solve the proportions depending the situation. The proportion we can use the fraction fraction equations just to tell you the truth. For example, In example number 1, you're going to identify an easy way in this situation. Solve the following proportions. You're going to see, this is an easy way how we can solve that situation. For example, in the letter A, we have this equation. X minus 5 over 3 equals 2x minus 4 divided by 6. Okay, we have this equation. If you see, it's a linear equation by means of using fractions. Okay, and actually, you at the beginning of this quarter, we solved this kind of proportions. Now we can proceed in this situation. Simple. Remember, the first thing that we had to do is apply cross multiplications. I mean, this number 6 divide passes to multiply, and this number 3 is divide passes to multiply using the cross multiplication, just like this one. 6 parentheses x minus 5 equals 3 parentheses 2x minus 4. Just like in the first step, okay? What will be the second one? The second one, we have to apply distributive property. I mean, 6 multiplied by x and 6 multiplied by negative 5. Also, 3 multiplied by 2x and 3 multiplied by negative 4. What will be the result? We got 6x minus 30 will be equal to 6x minus 12. All right, because we are applying the distributive property. Now we're going to join together the variables with the variables and the numbers with the numbers. You know, 6x minus 6x will be given by negative 12 because 30 is subtracting, passes to adding. Okay, what is going to happen? 6 minus 6 gave us 6 minus 6 gave us
12x. Well, zero.
no
Zero.
0. 6 minus 6 is 0. Okay, we got 0. 0 equals 30 minus 12 will be
Uh,
18, right?
yes.
18. And I have a question for you. Is this true? 0 equals 18?
No.
No. What happened? What will be then? This is not true. This is when you see an equal sign with a slant line, that means it doesn't equal, or it's false. That means that's equation. For that reason, this equation, this proportion, it doesn't have a solution. There is no solution. All right. In this example, there is no solution. And I have a question for you guys. What is the name of the linear inequalities or the system inequalities when it doesn't have a solution? What is the name?
Um. Uh.
Remember, we have 3 kinds, okay? What is the name?
Consistent.
Inconsistent. Perfect. Consistent is when we have a one singular solution, okay? This is going to be consistent. Inconsistent when it doesn't have a solution. Independent when we have an answer just like, for example, 5 equals 5, 10 equals 10, 11 equals 11, and so on, okay? This is how we can solve that situation, okay? Understood until this part or no?
Yes.
Okay, then let's going to solve another example. Okay, another example. A plus 2, letter B. A plus 2 over 7 equals A minus 3 over 2. A minus 3 over 2. Remember, this is the update of the proportions, okay? Because we have a rational equation, because we have a fractions into equations. What we're going to do, remember, once again, we're going to apply the cross multiplication. This number 2 is divide, passes to multiply. Just like that, 2 parentheses, a plus 2 equals 7 parentheses, a minus 3, okay? What we're going to do right now, simple, we're going to apply, once again, distributive property. I mean, 2 times a, 2 times 2, 7 times a, 7 times negative 3. Okay, Eunice, wake up, wake up. Oh, okay, sorry. What we're going to do right now is multiply 2 times 8 is 2/8 plus 2 times 2, 4 equals 7/8 negative 21, because 7 times negative 3 is negative 21. What we're going to do right now, simple, we're going to join the letters, the lighters, okay? I mean, we have 2/8 minus 7/8 equals negative 21, and the number 4 is adding, passes to subtracting. And you know, 2/8 minus 7/8 will be negative
Negative 5/8.
5/8. And this is going to be negative 25. And because the number 5 is multiplying, passes to divide, and you know, negative 25 divided by negative 5, the answer
Negative
will
5.
be, no,
Ah,
no, no,
no,
no.
5.
Well,
Yes.
the answer will be 5, okay? And has a solution. That remember, the solution set
It will be
in this case, the solution set will be number 5.
5.
Don't forget, it's this, even though we are talking about a proportion, because we have equations of using fractions, okay, it's another extension of the linear equations, okay? And what happened in this case? Let me show you. This is going to be interesting problem. And I'm going to move the camera a little bit down. No, a little bit downward. Okay. This is going to be the letter C. Okay. In the letter C, we have the same proportion. Like for example, aquí lo tenía, se me fue. Se me fue, se me fue, se me fue. Aquí está. 3 over x plus 1. 3 over x plus 1 equals 2 over x minus 2. Okay, what is the difference between the first one and the second one? Well, the difference is this time the denominators are located the x, the letter x, I mean the algebraical expressions. How to proceed? It doesn't matter. Is now where it's located in the denominator. We're going to apply cross multiplication also. We're going to copy this number 3 multiplying by x minus 2 equals this number 2 multiplying by x plus 1. And let's going to proceed to multiply then. I mean, 3 times x, 3 times negative 2, 2 times x, 2 times 1. Okay, so this is going to be 3x minus 6 equals 2x plus 2. Okay, what we're going to do, we're going to apply lighters. I mean, 3x minus 2x equals 2 plus 6. Conclusion, x equals, sorry, x equals 8. For that reason, the solution set, my dear students, will be 888. Questions?
No.
No questions. Okay, we're going to finish the class up to this part. And if God wills on Monday, we're going to solve a couple more examples of the proportions. And I'm going to teach you how to solving proportions by means of eh, word problems. Word problems that will be
It will
nice.
be Tuesday because in Monday we don't have
Yeah.
class.
You're right. I totally forgot. Gracias por recordarme. Imagínense que hubiera venido como loquito al colegio a dar clases y te encuentro todo cerrado. Es cierto, pero sí va a ser desde casa, ¿verdad? Entonces el día lunes vamos a continuar haciendo un par de proporciones, pero en vez de darle una ecuación, le voy a dar una figurita geométrica para que usted la cree. Le voy a enseñar cómo hacerlo. Y luego vamos a
El lunes no
estudiar,
tenemos clases.
bueno, el martes quiero decir, el martes, ustedes me entienden, ¿verdad?
Yes.
Y el martes, que terminemos eso con las figuritas geométricas, les voy a enseñar cómo interpretar y resolver word problems de proportions. Okay? Thank you so much for your attendance, guys. Have a great and wonderful vacations. Okay? Take care of
Bye,
yourself.
master.
Bye bye. So long.
Bye.
Take care of yourself. Sí, copiaron todo, ¿no? Perfecto.